Hello everyone, how are you? Today we want to discuss RSA algorithm for encryption and decryption, but please give me a second so I can um, tell my friend or my audience why I'm recording in English. مرحبا كيفكم؟ اليوم أنا مضطرة إني أسجل هذا الفيديو في الإنجليش مش في العربي لأنه في ناس طلبوا مني في الإنجليش فأنا بعرف إنه هذا الجروب للعرب لكن أنا مضطرة أسجل هذا في الإنجليش. Okay, so RSA algorithm is a kind of encryption and decryption algorithm and it's so secure. So in this presentation, I want to just give you some questions and answers, like some example to practice more in RSA. So in general, let's move to the other slide. So RSA, we have different equations and steps that we should follow to find different variables or parameters. And after we find those parameters, we can calculate the plain text and the ciphertext. So the plain text is the clear text before encryption or the message, and the ciphertext is the text after encryption. Okay, now to calculate the RSA, we have different equations and different parameters. The first one is P and Q, and P and Q are two main parameters that you select. It depends on your choice, but you select them in under one condition, which is P and Q should be both prime numbers. And prime numbers means what? The prime numbers are the numbers that divisible only by 1 and the number itself, correct? So for example, P and Q could be 3, 7, 5, 1. So all those numbers are prime numbers. But for example, 4 is not a prime number because I can divide 4 by 2, correct? So it could be again 3, 5, 7, and so on. Maybe 11. Okay, so after you choose P and Q, then you calculate N, where N is equal P multiplied by Q. Okay, N equals P multiplied by Q. Then you calculate something called theta of N, where theta of N is P minus 1 multiplied by Q minus 1. Okay, so those are just equations, and now we can like practice more on that. After you find theta, you should select integer e. For example, theta equals 40. Okay, so after you calculate, you find that theta equals 40. Then you should choose e, where e is greater than 1 but less than theta. This is the first rule. The other rule is e and theta are co-prime numbers, and co-prime numbers means that they do not have any common factors. Okay, they do not have any common factors. So if theta equals 40, I can choose e 7 or 3, correct? Because 7 or 3 are co-prime with 40. There is no common factors between 7 or 3 or 40. After you find E or you choose E, then you can calculate D, and we use D with decryption. Okay, when we decrypt, so in the equation of decryption, which is here, we use what? We use D. So how can I find D? This is the first equation for D, where D equals E inverse or e to the power negative 1 mod theta. Okay, but we have another two equations. I will show you in the next slide the best way to calculate D, because if I want to calculate D through this equation, it's hard to find. So the other equation is E multiplied by D equals 1 mod theta of N, and this one also is hard to find. I can't find it. Like, I need different calculations to find it. And the last equation which I use, D equals to 1 plus K of theta of N over E. And this is the best way to find D, where K could be 1, 2, 3, 4, etc. So every time we put K So in the first time we put k equals to 1 and we calculate, then we could put k equals to 2 and calculate, until we find what? Every time we find a number with decimal point, we move to the other one. So if I calculate k equals 1 and the final answer is a number with a decimal point, so I delete 1, then I try 2. If 2, the result is with decimal, I delete until I reach a result with the whole number, and this whole number did not have any decimal points. The whole number that I found will be d, for example. So let's take an example. If theta equals to 40, 40, and e equals to 3, okay? If theta equals to 40 and e equals to 3, so d, the first equation for d, when k equals 1, so it will be 1 plus k equals 1 multiplied by 40, it's 40 over 3, and this is equals to 41 over 3, which is equals around 13.6. So this is wrong. Why? Because I have a number with decimal. Now let's try the other one. What if d equals, now k equals 2, okay? Now k equals 2, so it will be 1 plus 80 over 3, correct? And this is equals to 81 over 3, which is 27. And yes, 27 is the whole number with no decimal points, so d is equals to 27. So now I find d. I can use d now with encryption, with decryption. Okay, so let's go back again to my equations. So again, we select p and q, where p and q are both prime, and then we calculate n, where n equals to p multiplied by q, and theta of n, where theta of n equals to p minus 1 multiplied by q minus 1. And then we choose e, where e is greater than 1 and less than theta, and e and theta are co-primes. After that, we calculate d, and then I can write my public key and my private key. Why? Because RSA is a kind of algorithm which is asymmetric algorithm, and asymmetric algorithm means that I have two keys. Symmetric algorithm is that I have one key, which is in the sender and the receiver sides. But RSA, we have two keys. So public key will be what? E with n. It's a pair of key, which is E and n. Okay, so after you find A, you put it here, and after you find N, you put it here. And the private key is D with N. Okay, we already find D and N, so we put it here. Now, I get the message and I encrypt the message. So the message is plain text, and I want to change it to ciphertext. So the message is, for example, 7, 6, or for example, the message is letters, text. Okay, how can I encrypt this one? So the ciphertext will be equal to what? The message itself, for example, the message is 7, for example, 7 to the power E, and we already choose E from here. Okay, mod N. So the message will be, so the cipher or the encrypted text will be the message to the power E, mod N. And then when you encrypt it, you send it to the receiver. And in the receiver side, I use decryption mode. So now in the decryption, the ciphertext will be changed to plain text again. And how can I decrypt? We use M equals to C, which is the ciphertext, to the power D mod N. So those are the calculation I want to use. Let's try to solve some questions and examples and practice more. But before that, I have some questions that we should answer. How to calculate big numbers of mode. Before this note, if you can see the note here, I forget to talk about this note. So about the note here, the note says if the number is less than the mode number, the result equals to the number itself, which means if the number here is less than the number in the mode, the result will be the first number. So 5 mod 8 is 5. Why? Because 5 is less than 8. 100 mod, sorry, with no E. 100 mod 120 is equals to 100. Why? Because 100 is less than the number that come with the mode. So anytime if the number before the mode is less than the number in the mode, so the result will be the first number. Now, what if the before this one, let's see how can I calculate mode. How can I calculate mode, and then we can come back to a big mode. Okay, so small mode again, small mode, if the number is less than the number in the mode, so the answer is the number itself. For example, 7 mod 20 equals to what? 7. Why? Because 7 is less than this number. Now, how can I calculate mode? So mode, for example, if I have 315 mod, let's say 25. Now, 315 is not less than 25, so we should calculate this one. There is different way to calculate mode. It's hard. Again, it's hard, but I find a good way, so I wanted to show you how can I calculate mode. So you should open the calculator. Sorry, let's go to calculator. Okay, now how can I calculate the mode? So I calculate the mode by what? I will divide 315. I will divide it by 25. So after you divide, you will find digits and then decimal point and then digits, correct? Anything before the decimal point should be subtracted. Okay, so for example, the answer was x, y, z, which is numbers, dot something. So those x, y, z should be subtracted. So let's see. Again, go to the calculator. Okay, so let's calculate this one. So 315 mod 25. So first thing you should divide by 25. So the answer is 12.6. Again, anything before the decimal point should be subtract. So minus 12, it's 0.6. Now this 0.6 will be multiplied by 25, which is in the mode. So multiply by 25, it's equal to 15. So this is the answer. So the answer of 315 divided by 25 is 15. Let's take another example. For example, 1917 mod, let's say mod 36. Okay, so go again to the calculator. Now divide 917 divided by 36. So the answer is 35.25. Now anything before the decimal should be subtracted. So negative or minus 53. And then this number should be multiplied by 36. So multiply by 36 is equals to 9. So the answer is 9. So this is how can I calculate mode. So mode, again, if the number here is less than the mode, so the answer is the number itself. If the number is greater than, you calculate. But what if the number is so great? So great or so big means that we cannot calculate it with the calculator. And we should use the regular way for mode, which is so difficult. So let's go to the calculator first and try to find this. So the question says, what if we have 51 to the power 26 mod 55? So 51 to the power 26 is equals to what? It's a huge number, plus e to the power 44, which is so huge, so I cannot calculate it within the calculator. So the idea is, if you remember in math, if I have x to the power 13, for example, it's equal to x to the power, for example, 5 multiplied by, sorry, so let's delete this one. Okay, multiplied by x to the power 5 multiplied by x to the power 3, correct? And this is equals to what? It's equals to x. So when the number is the same, we can do summation for the power. So it's x to the power 5 plus 5 plus 3, which is equal to x to the power 13. So x to the power 13, it's the same number as x to the power 5 multiplied by x to the power 5 multiplied by x to the power 3. Okay, here's the same. So 51 to the power 26 is equals to what? So 51 to the power 26 is equals to what? It's equals to 51 to the power 5 multiplied by 51 to the power 5 multiplied by 51 to the power 5 multiplied by 51 to the power 5 again, multiplied by 51 to the power 6. So it's 5 plus 5 plus 5 plus 5 is 20, plus 6 is 26. So this is equals to what? It's equals to 51, correct, to the power 5 plus 5 plus 5 plus 5 plus 6, which is equals to 51 to the power 26, correct? So how can I calculate the mode here? So let's erase everything and let's calculate the mode. So the mode here is equals to what? It's equals to 51 power 5 multiplied by 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 51 power 6 mod 55, correct? So let's calculate each one, which means I want to calculate 51 to the power 5 mod 51 and multiply at different time. So let's find the first thing. I want to find 51 to the power 5 mod 55, which is here and here and here and here. And I also want to find 51 to the power 6. So also I want to find 51 to the power 6 mod 55. So let's find both of them. So let's go back to the calculator and let's calculate together. So 51 to the power 5 is equals to what? A big number, okay? Divided by 55. So we have this number. Anything above the decimal, we should delete it or subtract. So minus 6, 2, 7, 3, 1, 8, 6. Now this one should be multiplied by 55. Multiplied by 55 equals to 21. So the answer here is 21. Now let's find this one, okay? So let's go to the other one. So 51 to the power, now we want to calculate 51 to the power 6 divided by 55, and then delete or subtract everything at the left side of the decimal number. So now minus 3, 1, 9, 9, 3, 2, 505, and this number should be multiplied by 55, which is equal to 26. So the answer here is 26. Now, what's the answer of this one? So this equation would be what? It will be 21 multiplied by 21 multiplied by 21 multiplied by 21, which is this and this and this and this, and then multiply by 26 mod 55. Now it will be easier to calculate. Okay, go back to calculator, and then 21 multiplied by 21 multiplied by 21 multiplied by 21 multiplied by 26 equals to what? This number, mod 55. Now I think to the left of the decimal should be deleted, so minus 91,936 multiplied by 55 is 26. So the final answer is 26, which means 51 to the power 26 mod 55 is equals to 26. Okay? Okay. So now we talk about RSA equations and steps. Then we talk about how can I find the mode if the number is small, if the number is regular, or if the number is big. Now, how can I calculate D again? D have three equations, so I can say that D equals to E inverse mod theta of n, which is hard. I cannot find it. I can find it, but it's like it's take a lot of time, and this is not useful, especially in the exam. The second equation is D multiplied by E equals to 1 mod theta of n, and this one is hard to find. The last equation is D equals to 1 plus k theta of n, okay, over E, and this one is easy, where k is equals to 1, 2, 3, infinity, until I find what? Until I find the result with the whole number, no decimal points. Okay. Now example 1, let's make an example. So example 1 says, I have a message, and my message is m equal to 7. So I want to encrypt this message, and I want to decrypt this message again. So let's follow the steps. So the first step says that we should select P and Q, correct? Where P and Q are prime numbers. So let's say if P is equals to 17, for example, and Q equals to 11. Then we should select what? We should calculate what? N, where N is equals to P multiplied by Q, and this is equals to 11 multiplied by 17, which is equal to 100. Okay, it's equals to 187. So this is N. Okay, so we find N, we have P, we have Q. Now theta of N equals to P minus 1 multiplied by Q minus 1. And this is equals to 11 minus 1, which is 10, multiplied by 17 minus 1, which is 16. And this is equals to 116. And this is what? This is theta of N. So we find this one also. Now E should be greater than 1, less than theta of N, correct? While E and theta of N should be coprime. So theta is 160, so I think we can say that E equals to 13. for example. So we find E. Okay, now let's try to find D with my equation, which is 1 plus K of theta of N over E. So if K equals to 1, so it will be 1 plus 160 over 13. So it's 161 over 13. So let's see the calculator. 161 divided by 13, which is 12.30. So it's a 12.38, and this is wrong. So what if K equals to 2? So if K equals to 2, it will be what? It will be 162. No, sorry. So if K equals to 2, it will be 1 plus 2 multiply 160. So plus 2 multiplied by 160 over 13. So let's see on the calculator. So 2 multiplied by 160, okay, plus 1 over 13, 24.6. Oh, sorry. Okay, so 24.69, which is wrong. So what if K equals 3? So 1 plus 3 multiplied by 160 over 13, and this is equals to, so 3 multiplied by 160 plus 1 divided by 13, 37, which is whole number. So this one is correct. So 37, which is D. Okay, so we find P, Q, N, theta, and D. So everything is correct now. So let's erase, and I want to write them here. So in a small line, like small. So P, again, P is 17, and Q is 11, and N is 187, and theta of N is 160, E is 13, and finally D is 37. Now the message, which is 7, I want to change it to ciphertext, correct? Ciphertext is C, where C is equals to the message to the power E mod N. Message is 7, power E is 13, mod N is what? 187. And this is equals to, so let's see the calculator. Okay. So 7 to the power 13 divided by 187. Now anything above the decimal should be deleted. So minus 518 3050 multiplied by 187. So the answer is 57. So the answer is 57. Now the ciphertext, so cipher is 57. Now I send it within the lines, even if it's a wire or wireless. So I send it to the receiver. Now the receiver he want to read the message. So before reading the message, I said decrypt. So decrypt means that from cipher to message. So message equals to cipher to the power D mod n, and cipher is 57. Sorry. So cipher is 57 to the power D, where D is 37. Okay. Mod n, where n is 187. This one is big number. This one is big number. So this one is equals to what? So it's equal to 57 to the power 5 multiplied by 57 to the power 5 multiplied by 57 power 5 multiplied by 57 power 5 multiplied by 57, sorry, 7 power 5 multiplied by 57 power 5, so 10, 20, 30, and then multiply by 57 power 7 mod 187. Now we should calculate 57 power 5 mod 187. I'm back, sorry. Okay, so now we have to calculate what? 57 power 5 mod 187 and multiply it 6 times, and then multiply it with 57 power 7 mod 187. So let's calculate both of them. So let's do it here. Okay, so 57 power 5 mod 187 and 57 power 7 mod 187. Okay, go back to calculator. Okay, so 57 power 5 mod 187. Now anything above should be delete, so minus 3,217,604 multiplied by 187. So the answer is 109. Okay, so let's calculate the other one, which is 57 power 7 divided by 187 minus 10, 4, 5, 3, 9, 9, 7, 2, 8, 9 multiplied by 187. So the answer is 150. So the answer is 150. So here it's equal to 109 multiplied by 150 mod 187. So let's calculate this one. Okay, so let's calculate this one, which is 109 multiplied by 150. Okay, mod 187 minus 87 multiplied by 187 So the answer is 81. Oh, so the answer is, okay, we have something wrong because the answer should be, the answer should be 7. So I did something wrong, but I'm not sure what is it. So 5, 5, 5. Okay. Something is wrong. So I want to stop the video, check the wrong, and come back. Okay. Okay, find the error. The error is, so the error here is, let's take a pen. Okay. So the error here, it's 109, 1, 2, 3, 4, 5, 6 times. So let's delete this. So let's delete the last one. Okay. So it will be 109 multiplied by 109 multiplied by 109 multiplied by 109 6 times, correct? Multiply by 109 multiply by 109, so 1 2 3 4 5 6, and then multiply by 150 mod 187. So let's calculate this one. Okay, so it should be 109 multiplied by 109 multiply by 109 multiply by 109. Oh, so 1 2 3 4 5. Okay, multiply by 109 and then multiply by 105. Oh, sorry, 150. Okay, this one, and then divided by 187, and then delete anything above the decimal, so it will be minus 1 3 4 5 2 6 7 4 6 8 5 8 9 multiply by 187. Okay, great. So the answer is 7. The answer is 7, which is what? If you take a look here, so the answer here will be 7, which is what? Which is the main message. So the message was 7. We encrypt the message and it becomes 57, and we decrypt the message and it becomes 7 again, which means you write a message. For example, you write a paragraph, you encrypt this paragraph and send it on the internet. Then the receiver decrypt this paragraph again to read it. Okay, so this how you can make sure that your answer is correct, because the last answer should be similar to the plain text or the clear text. Okay, so let's take another example. So they said encrypt the message, which is 6. So now the message is 6. Okay, so let's take a pen. Okay, so the message is 6. Where, so they give us P and Q. So sometimes in the exam, they may give you P and Q. So P is 5, Q is 11, N is what? N is Q, P multiplied by Q, so N will be 55. Theta is what? Theta of N is P minus 1 multiplied by Q minus 1, so it will be 4 multiplied by 10, which is 40. And then E, you can choose E, so let's choose E equals 3. And then D, so let's find D. So D equals to 1 plus K multiplied by theta of N over E. So if k equals 1, so it will be 40 plus 1, 41 over e, which is 3. Oh, sorry. So e is 3, and this is equals to around 13.6, which is wrong. Now what if k equals 2? So if k equals 2, it will be 81 over 3, and this is equal to 27, which is correct. So D equals 27. Now let's delete those and start doing our equation. So M is 6. So the ciphertext will equals to what? M to the power E mod N. Okay, where M is 6, E is 3, mod 55. And this is equals to, let's calculate this. Okay, calculator. So 6 to the power 3, 216 divided by 55 minus 3 multiplied by 55. So the answer is 51. So this is what? This is the ciphertext. Now you send the ciphertext to the receiver, and then the receiver wanna read the message. So the receiver should decrypt. And decrypt means what? Decrypt means that M equals to C to the power D mod N, where C is 51, D is 27, mod N, which is 55. So this one is big, so it will be 51 power 5 multiplied by 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 51 power 6 mod 55. And I think we calculated this one before. Which is here. So the answer is 26. Correct? The answer is 26. Are we sure? I don't think so. So let's calculate it, because the answer should be 6, which is the message. So let's calculate this one. Okay, 1, 5, 10, 15, 20, 20. Okay, so it should be 27 here. It's not 26, it's 27. Okay, so let's find, so 5, okay, so I can take this one. So because it's 21, so 51 to the power 5 is 21, and then we calculate the other one. So the answer here is 21 multiplied by 21 multiplied by 21 multiplied by 21, and we can calculate this one. So let's calculate this one, which is 51 to the power 7. Okay, so 51 power 7 divided by 55, now minus 1631 655 7779. Now multiplied by 55, so it's 6. Okay, so here, oh sorry, here we have 6. Sorry, so here we have 6. Mod, oh my god, sorry for that. So mod 55. So let's calculate this one again. Calculator. So it's 21 multiplied by 21 multiplied by 21 multiplied by 21 4 times, yes, 4 times, multiplied by 6. Okay, divided by 55 minus 21216. Okay, multiplied by 55. So the answer is 6, which is what? The main message. So our solution is correct. So now the answer here is equals to 5, it's equals to 6, where 6 is what? It's the original message or the plain text. So the plain text was 6, and then we decrypt it, and it was, so then we encrypt it and become 51, and then the receiver side we decrypt it and become 6 again. Okay, great. The last question. Okay, so the last one is, what if the message is letters like cat, car, book, paragraph? Okay, how can I encrypt letters? So before you encrypt letters, you have this table, and each letter have a number. So from A to Z, we have numbers from 1 to 26. Okay, so now we will put a number instead of each letter. So the first letter is C, which is from cat. The second one is A, and the last one is T. Okay, so let's remove this part. Sorry for that. Okay, so T. Oh, sorry. Sorry again. So let's take a pen. Okay, so the last one is T. So the easiest way is to make this table. So this table, we have the plain text, which is cat. So it's CAT, cat. But the number for C is 3. The number for A is 1. The number for T is 20. Then you put the ciphertext, and then, which means encrypt, and then you decrypt, and then you give me the letters again. So let's try for C. Okay, so the first one is for C. Okay, so C, it's similar to when we said that the message is, for example, the message is equal to 3. It's the same. Now let's choose numbers and Q and everything. So let's say, for example, P equals to 3, N equals to 33, P equals to 3, Q equals to 11, N equals to 33, and theta, which is P minus 1 multiplied by Q minus 1, so it's 20. And let's say we choose E7, and let's say we calculate D, and we find that D, oh, sorry. So this one is E, so E equals 7, and let's say that we calculate D on the equation, and we find that D equals 3. So you can calculate this one, but I want to do it so quick. So let's say those are the variable that we have. So C equals to 3, correct? So the message, the first message was 3, and I can cipher this message by using M to the power E mod N. Okay, and this is equals to what? M, which is 3, to the power E is 7, mod what? Mod 33. Now we will find the solution, but let's do the other one. So when the message is equals to 1, which is A equals to 1, so then the ciphertext will be 1 to the power, let's write it here. Sorry, wait. So let's write it here. So it will be 1 to the power 7 mod 33. And if M equals to 20, which is here, letter 3, which is letter T. So the ciphertext will be equals to 20 to the power 7 mod 33. So let's calculate all of those together. So let's move this here. Okay. So the first one is 3 to the power 7, okay, mod 33 minus 66 multiplied by 33. So the answer is 9. So here the answer is 9. The second one, without calculating the second one, 1 to the power 7 is 1. And we said if the number here is less than the number here, correct? We said that if the number here is small, so the answer will be the number. So the answer will be 1. Now this one, 20 to the power 7. 20 power 7 divided by 33 minus 38787878. Okay, too many 7/8. Okay, multiply by 33, so the answer is 26. So here the answer is 26, correct? So this is how we encrypt. So the encrypt will be 9 1 26. Now decrypt. How can I decrypt? Now decrypt is M equals what? C to the power D mod. So let's write this one like above. Okay, so here M equals C to the power D mod N. So this one will be what? 9 to the power D, which is 3, mod 33. And this one will be 1 to the power 3, mod 33. And this one will be 26. Oh, sorry. So this one will be 26 to the power 3 mod 33. So let's calculate each one. So calculator. Okay, so let's try to calculate this. Okay, so 9 to the power 3 equals mod 33 equals 3. Okay, so this one is 3. Now 1 to the power 3 is 1, and 1 is less than 33, so this one will be 1. And the last one is 26 power 3 mod 33. Okay, minus 532 multiplied by 33, and this is equals to 20. So the answer here is what? Here it's 20. So if you can see 20 here, it's here, and 1, it's here, and 3 here, it's here. So when we decrypt, it will be 3 1 20, and when you compare this one, it's similar to this one. Now 3 from the table is C, 1 from the table is A, and 20 from the table is T, so cat becomes cat. So cat in the sender encrypted to 91626 and then send it with the wired or wireless to the other side, and the other side decrypted and become cat again. So this is everything. Thank you for listening, and if you have any questions, you